Hey everyone, this is a quick refresher or recap on the SQL part. If you are already good at the SQL part, then you can skip this video. If you want some kind of refresher, you can just watch this really quickly. I'm going to use the built-in schema here. So I'm going to use the employees table. Let's see if we can find the employees who are not managers. So let's see if we want to select all from Scott.m. right, and let's just head this, and you're going to see that you have multiple people who are not there you have a president, you have a manager, analyst, clerk, and salesman. So we want to get people who are not managers, so you can just simply add a where close where the job, notice that this is the job title, right, where the job is not equal to manager, right. So let's run this. Okay, so you get president and analyst and clerk and salesman, people who are not managers. There are another way that you can find people who are not managers, right? So this is the first one. The second one, which is a little bit unusual, but I just wanted to tell you about it, is that you can use one of the set operators. So the set operators is about union, intersection, and difference. Okay, so to illustrate this, let's say we have these three tables, R1, S1, and S2, and for using the union or intersection or the difference, right, you need to make sure that the tables that are being unionized or differentiated or intersected are union compatible. And by union compatible, it just simply means that the number of columns needs to be the same between the table that you are unionizing on or the table that you are differentiating on or intersecting on. So the number of columns need to be the same and the type also need to be the same. So let's say, for example, that I will say S1 minus S2, which is basically a difference here. This means that if there is any row in S2, subtract it from S1 if it exists in S1. Alright, so if there is any row in S2, subtract it from S1, and whatever is left over in S1, just display it. Right, so let's go to S2. You're gonna have something like Lupper, this row, Lupper in S1, and you have Rusty in S1. So whatever rows that happens to be in S1, the one that you are subtracting from, just take them away, and whatever is left over or whatever is left off of S1, just display it. In this case, if you subtracted Lupper and Rusty from S1, you're just going to be left with Dustin, this row. So this is what is going to be displayed here. With the same exact fashion, we can do the same thing. We can say, if we want to get people who are managers, let's get people who are managers first and subtract it from the entire table. This is going to be leaving you with president and analyst and anything who was, or any job that is not actually a manager. So let's see how this is written. So let's say that this is going to be the query that is going to be subtracted from. So this is selecting everything, and notice that the selected columns needs to be matching from the table that you are subtracting from and the table that you are subtracting. Okay, so select all from Scott.m like that. So this is the first table, and I'm going to subtract from it all of the rows that happen to have the job of manager. So I'm just going to say minus, which actually equivalent to the minus symbol, right? And this is the second query. Select all. Notice that this is important, right? The one that you are subtracting from, the number of columns of this query needs to be the same number of columns of the query that you are subtracting from. Okay? In the joining case, whenever you are joining, that's not really an issue. So the number of columns that you are joining from a table on another table doesn't need to have the same number. Okay, but in the case of set operators, they need to be what we call union compatible. So the number of columns and type needs to be the same number of columns and type. Okay, so let's select everything from the same table, but where job is equal to manager. Okay, so essentially the inner query, which is the one that you're subtracting, right, is going to get all the rows that has the job manager, and it's going to subtract it from this one. So whatever is left over of this one is going to be displayed. So let's try this. Okay, so you get everything that is not a manager. So it's the same thing as before, but that's just using the set operator if someone wanted to use the set operators. Alright, so let's continue with the second query. So here you're saying that you want to get all people who are managers. Okay, so this is as simple as that, but if you notice something, I'm just going to hit this. So these are people who are managers, but that's not quite true. So if we just run this query alone to select every row in the table, you're going to see that there are people who are acting as managers. It doesn't have to be the job titled as managers. You're going to see, for example, King, who has the employee name number of ending with 39. He is actually managing Blake. So King is a president who is actually managing Blake, and Blake is let's see, who is Blake is managing. So yeah, Blake is managing Allen and Ward and Martin and Turner, right? Let's see Clark, for example. Clark, he's managing 82. He's managing Miller, the clerk. Alright, and even for analysts like Scott, if you take a look at Scott, for example, you're going to see that Scott, ending with 82, he is managing Adams, who's a clerk, right? So it doesn't have to be someone who's titled as a manager to be a manager or to be managing someone. So let's find employees who are just managing someone else, right? So let's see how can we do that. The simplest way to start thinking about this is that you see that employee number, right, happens to be existent in one of the rows as a manager number as well. So for example, for King, this employee number has existed in this row as a manager number, and in this row as a manager number, and in this row as a manager number. So it really looks like if it's some kind of a nested loop that you need to implement, meaning that if you are standing in this row, so just pick this value from this row, which is under employee number, and compare that value from this row, which is actually fixated now, right? We're not moving anywhere, we're just in this row. So pick this value and start comparing it with every manager value from the upcoming rows. And if you find that this value from the row that you are in, right, from the outer loop or the outer query, if you find that value in the next couple of rows under manager, then this means that this guy is actually managing someone, right? So if I find this guy here under the manager, so this means that this guy is managing someone. So this is an indication for me to select that row that I was initially standing on in the outer query. Same thing goes if I, for example, if I picked, for example, the analyst Scott, for example, here, right? So I'm just going to stand on this in the outer query, right? And the inner query or the inner loop is going to run and compare the employee number of the current row that I'm standing on with the next upcoming values of the manager column. Then select that row that you are standing on, okay? So that's just easily, this is a correlated query, because you are grabbing some row from there and you start running on another query, right, while you are actually grabbing the value from this row, and you are comparing this employee value, this employee number value, with every manager value from the upcoming rows. And if this employee number was found to be equal to one of these manager values in the upcoming rows, right, for example, it is going to be there, yeah. So if this value existed in the upcoming rows in the inner query, then that means that this value from the row that we have been standing on in the outer query, this means that this value, actually this guy is a manager. So select that row and display it to the as a result to the screen. Okay, so this is easily done via a subquery. Okay, and just to remind you, subqueries can be either nested queries or they can be correlated queries. And most of the time when we are using nested queries is a little bit different, where, as we discussed before, the inner query executes first. Once the inner query is done executing, you execute the outer query. And most of the time you use something like in or all or any operators, right? To like link between the two queries, okay? The correlated query, on the other hand, the inner query is running against every row from the outer query. So they are running in conjunction. That's just the same idea of a nested loop as we've discussed before, right? So most of the time we're going to see the keyword exists being used, or the negation of it not exist, and the same for these, the negation of these guys for the nested query, not in, not all, not any, right? But most of the time we're going to see exist or except. You didn't really take except, so I'm just going to stick with exists, right? You might see also most of the time that exist is the operator that links the two queries together, plus the condition. The condition, where you actually say that from the row of the outer loop, I'm going to grab this value and check if it is equal to the values for example, from the manager column of the upcoming rows, right? So this is the condition. Employee number, is it equal, is it greater than, is it less than to, for example, the manager column of the upcoming rows? So condition plus exist, this is what we use most of the time to form a correlated query. So let's see how this is actually going to turn out. So I'm just going to, so let's do a correlated version first. So I'm just going to make a correlated answer here, correlated query, related one here, okay? And I'm going to select everything from the Scott.employee table, right? Where let's say that this start, this asterisk, mean that you are selecting all of the columns, okay? So I want to make sure that the outer query, right, whenever it executes, let's say that it has executed for a first time and we are standing on the first row, right? So from the selected value, I want the value under employee number to check if it is existent in the upcoming rows as a manager or not. So I'm just going to say where exists in the upcoming rows of the same table. So I'm just going to do it like that. Select all from the same table like this, right? But notice that now you are comparing every row that you are grabbing with the rows that are being grabbed from the same table. The Oracle DBMS is going to complain because it's going to tell you that this table is the same table. So do you mean that we are checking the rows from the same table, or is this some kind of a copy? Meaning that, for example, if I left it like that, first of all, it's going to throw an error, because what is Oracle going to try to do is that if you are standing on this row, it is going to start comparing with the second row, right? But that's not how nested loops work. If we have a nested loop, then this means that I'm going from the outer loop, going to grab this row and compare it with itself first, then I'm going to go through the rest of the rows, right? So we need to tell the Oracle system that, and this is one of the scenarios that you're going only to find in correlated queries or in joins, where you are going to need to differentiate between the columns that you are comparing rows against, right? Or from the tables that you are comparing its rows against each other. Okay, so you need to name this. Let's make this actually in 2 lines, and I'm going to say this as table 1 and this is as table 2. Okay, but this is actually not complete, so I'm just going to show you what this sketch is actually saying real quick. Alright, so what we have done in most of the time in correlated queries or in joins, right, we treat, even if we are talking about the same table, like in this case we were talking about the same table, but we gave it an alias of T1 and the second an alias of T2, for the purpose of comparing each row from this table with the other rows from the other table, from the same table, but just as a copy of it, right? So what we have done here is basically because we wanted to do that. So let's say that this is the outer table, which is going to be representing the first loop or the outer loop, and this is the same table, which is, we can consider it as a copy of the same table, and we named it as T2, and this is going to be the inner loop or the inner table that we are comparing against. So what happens is that we want to grab the first row like this and compare it with every row with the from the copy table, or from the copy table. So I'm just going to start with the first table, with the first row itself, the same row that you are standing on. If I didn't find, for example, the value of the employee number from the first table equaling the value from the manager, then I'm going to skip that row and go to the second row, right? And I'm going to see, is the value from the table that I'm standing on, which is being fixated right now, is the value under the employee number from that row, is it equal to the copy table's manager value from the second row that we are checking in the inner table? Is it equal? If it's equal, then this is an indication that this guy is actually managing someone, right? It doesn't have to have the job manager as a manager, but he's managing someone. So if this is the case, then we can just stop iterating over the rest of the rows and just grab that row there from the outer table and display it to the user via the select star from T1 that we have written, right? And once we do that, right, once we found an equality in the inner loop, right, we are just going to go back to the outer loop or the outer table, and we are going to continue comparing the other rows. So I'm going to go to the second row, right, from the outer query, right? Is this employee number equal? Let's start the inner loop from the start again, right? Just as any inner loop or nested loop works. So I'm just going to grab the second nested, or the second row from the outer table T1 and compare it with the first row of the copy table, right? Is the employee number equal to manager from that copy table, from that row in the copy table? No. So go check the other one. Is the employee number equal the manager value in the second row of the copy table? No. So keep on going until you find this guy here. All right. Whenever we reach this row from the inner query or the inner table, which is the copy table, you know that this guy is actually a manager. He's managing someone because he is under the manager column. And this is an indication that we need to stop executing the inner query and just go to the outer query and select that row that we have been standing on and display it via that select statement, right? That select statement to the user. And once we made the selection of a current row from the outer table, we are going implicitly to continue comparing the rest of the row of the outer table with the rest of the rows of the inner table, which is the copied table. All right. Okay. So the condition of equality, we didn't actually write it. This is the only thing that has been missing, right? So we want to compare every row from the outer table with every row from the inner table based on the employee number from the outer table. If it is equal, if we found the row that has an employee number from the outer table that is equal the manager from the inner table, MGR, right? I think there is a where here, right? If we found something like that, then this is existent, and this value actually existent. So this is going to return true. So return that row that you have been standing on the outer table. Okay, I hope this is clear. Okay, so let's just execute that. Okay, and you get people who are actually managers. That makes sense. And people who happen to be analyst or president, right? Scott, for example, he was managing someone else, and King, as the president, he was managing someone else, and so on, and Ford, and so on. Okay. Okay, let's see how can we do this via a join, right? So this is a correlated query. Remember, in the last lab, I've said that correlated queries are the same as joins. So let's see how can we do that via a join. It's pretty much easier than this, right? It's the same concept that we want to combine the two tables, which is basically it's the same table, but we are combining the two copies of the two tables together because we want to put them side by side and compare. Is the employee number from that table is equal to the manager value of the joined on table or not? Okay, so I'm going to join from this table, let's just write this like that, scott.emp as t1, inner join it on the same table, but just as a copy of it, right? On what do we want, how do we want to link the rows from that table with the rows from that table? Well, basically based on their employee number and manager, right? So this is the benchmarking, this is the comparison that we're looking for, right? So I'm just going to grab here, I just want to remove all of this. Okay, so what is going to happen is that you are going to, for example, join this table. So you're going to grab the row from this table with the row from the same table or the copy table where employee number equals managers. So this is going to be joined with this, right? And this is going to be joined with also the next one, since you have employee number equals to manager in the next row or the third row, and the third or the fourth row as well. Okay, and this makes sense since actually King, who is the president, King is actually managing 3 people here. You can tell from this number repeating 3 times that he's managing the 3 managers. He's managing Blake and Clark and Jones. Yeah, he's managing these three people. So it makes sense. So whenever you join this table, on this table, based on whatever equality between employee number and manager from this table and this table, you're going to find, for example, this row repeated or is conjunctioned or unionized or joined with this row and this row and this row, right? So it makes sense to see something like that, right? And if you go to Blake, you're going to see that Blake, for the second row, actually Blake is managing, it doesn't show in this snippet, but let's take someone who's actually there. Let's take let's take, for example, Jones here. Jones is a manager, 66. So this row is going to be joined with this row here, because he's actually managing Ford. You can tell that he is managing Ford, right, and so on. Okay, so let's see how this is looking like. Based on, from the first table, the employee number equals the manager from the second table. Okay, so let's check the first one. The order doesn't really matter here, but let's see. We said that King is going to be repeated 3 times, right? So we said that, where is it? Okay, let's just bring it again. So we said that King is going to be joined with these 3 rows because he happened to be a manager of these 3 employees or managers, right? So we've seen that King now, all of the values from the first table, see that this is the first table, right, on the left here, this is T1, that's the first selection, and from this part, this is the joined on table, that's the second table that we are joining on, which is T2, right? And the basis of join is basically employee number from T1 equaling the rows where that number happens to be the same under the manager column, right? So King employee number happens to be the same under the manager column from the second table here, there, and there. So he manages 3 people, Blake and Clark and Jones, and these are their 3 IDs. Okay, but the thing is this is kind of redundant, right? First of all, we want to specifically only display the people who are actually managing someone, which are the resultant on the left hand side here. Okay, so you know that Jones and Blake and Clark are managing people. Basically, the repetition here means that Blake is actually managing 1, 2, 3, 4, 5 people. So Blake is managing Alan, James, Turner, and Morton, right? Analyst, the Scott is actually managing someone, only one person. King is managing 3. So the repetition here, or the redundancy, is just because we are joining on the second table, and it happens in the second table that these people are actually managers of or managing a couple of employees. That's why you're seeing them redundant. Okay, So if we want to only have the result on the left hand side, which is this part, which is basically people who are managing someone, we can restrict the things that we are actually displaying. So maybe I would want to display employee number and e-name and job from the first table, right? From the result of the first table, that is basically this part here, right? T1, all right? So I can just say from T1 display to me employee number, and notice that specifying the table that you are projecting the values from under its columns is important, because you happen to have employee number at both tables, right, or at both sides, from the joined on table and the table that you are joining on, right? So from the joined on table, employee number actually represents people who are being managed, people who are managed, but we want to see people who are managing someone else. So it's basically the result on the left hand side, so from the T1, from the first table. So I'm just going to say employee number T1. Let's get the name as well, and let's get actually that's it. I just care about this, yeah. So let's run this, and there's still a redundancy, and we know that we can solve this easily by distinct, right? So we can just add distinct. Okay, so now I get all of the employees who are actually managing someone else. All right, we can make it clearer and add just one last attribute here to show their job as well, just to indicate that they are not only managers. We have people who are presidents and analysts who works as acting manager. Okay, let me just take the same exact join and put it there, and I'm going to display everything to show you just a quick thing that you can do. The beauty of this is that on the left hand side you have the first table, which is T1, right? The first selection here. Okay, so this represents actually people who are managing, and on the right hand side where actually manager equals that employee number, right? Manager equals employee number on the right hand side, basically the second table that you are that is being joined on, just T2, right? Okay, the second table represents people who are being managed, right? People who are being managed. Okay, so we know that Ford and Scott and Alan and James, or let's say Ford and Scott, for example, are being managed by Jones. Okay, so if we know something like this, we can immediately formulate a new query, and let's try to find people who are or managers. Let's start with managers there. So let's see managers, not normal employees who are being managed by someone else. For example, we saw that let's see here, Ford is managing someone else, right? So Ford here is managing clerk or Smith, and in the same time we've seen Ford before, like Ford actually was here on the right hand side as well. So this means that Ford, that he's an analyst, right? He's being managed by Jones. Okay, so let's try to get people who are managed by someone. Let's start with normal employees. So I'm going to pick from the second table here. So I'm just going to say pick from the second table employee number, and pick employee name, pick the job, and we can actually pick their managers as well, like that. Okay, employee number. Okay, and you're going to see these are the people who are being managed by. Okay, but we want to grab from them people who are actually managers. So people who are actually managers who happen to be managed by someone else, right? Before we do that, let's see who are managing these guys. Remember, the entire join without selecting anything like that means that you have two sides, the left hand side and the right hand side, and the left hand side from T1 had people who are managers. So you can just say that I'm going to say from T1 ename, and I'm going to give this an alias of managed, or I'm just going to put this at the end so it makes more sense, right? So T1 ename, and this is going to be managed by. Okay, so Ford happens to be managed by Jones, and Scott is managed by Jones. Okay, and we see actually that Smith is managed by Ford. Okay, so we want people who are actually managers. We want managers who are being managed by someone else. This is just employees who are just being managed by someone else. But we want to specifically say, I just want to show you that you can add a where clause to your join, that's totally fine, where T2 the job, right, equals managers. So we want managers who are being managed by someone else. Okay, so in this case you have Blake and Jones and Clark who are being managed by the president, which is King. Okay, let's take another last example on this built-in schema here. So let's find employees who are managing someone and are getting paid 3,000 or more. All right, so employees who are managing someone, we've seen this before. Employees who are managing someone, we've did this via the correlated query and the join. Let's take the correlated one. Okay, so let's run this and see the first bar, which is employees who are managing someone. Okay, so employees who are managing someone, they happen to be all of these guys, right? Now we want to say employees who are managing someone and they are getting paid a salary of 3,000 or more. So you can just add an aware clause after all of this is ending, right? So after all this ends, we can just add to that where clause. So where this is true, if this is true, then we are going to select that row. But remember that I just want to make sure that the salary as well is greater than or equal to 3,000. Okay, so you got the president and the analysts, Ford and Scott. We can do that via another technique, which is basically using the intersect, if you remember the set operators. So here the intersect means where do they share the same attribute. For example, we want to see where S1 intersects with S2. So S1 has Dustin and Lubber and Rusty. S2 has Lubber and Rusty. So they actually intersect in the row that has Lubber, right, and the row that has Rusty. So it's going to return the common between the two tables. Okay, so using the same query, I'm just going to use this like that. That's just a different way of doing this, right? And since I will use intersect, so it's going to be pretty big, so I'm just going to write all of this in one line. That's totally fine. So this is the first query that actually returns people who are just managing someone else, right? And we want to intersect that with the following query. So select all from Scott. Notice the union compatible condition. These needs to have the same number of rows, right, from the same table. Okay, actually the alias here and this one is not, it doesn't really matter. And the second intersected, like the second query here, the alias, I don't have to give an alias. This alias was just there for this first query, right, which is a correlated one. But anyways, the second query is going to select every row from the table where the salary is greater than or equal to 3,000, right? So any row that has the value 3,000, right, we will see, does that row is it there in this first query? If it intersects, if the same row intersects from this query with that query, then this is going to be displayed. Okay, so this should give you the same result. Alright, I wanted to give you a couple of examples on the stuff that we have made as well inside the lab, in the previous lab, where we said that we have this ER diagram. We've made a use case that has a student, course, and department that takes relationship is many to many. So we decided that this is going to be having its own table. There is a table for student and course and department as well, and there was a table for the multi-value attribute column that is called availability, which means that a course can be taken either online or on campus or both of them. This actually prevents the multi-value thing inside a column. So we are actually adapting or implementing the first normalization form, right? By by taking the multi-values or multi-valued column or attribute and make it its own separate column or separate table. So what we did was we created this department, the student, the course, right? And for the multi-value attribute, I called that table course availability or course avail. So C number, which needs to be referenced from this guy is referenced from the table that is called course, where the actual table that is called course has a primary key that is called C number, which is this one. So C number here is a foreign key referencing a primary key from course, right, with the same name. And the avail attribute, which basically means that it's either on campus or online. For example, if you have, this is the final result, by the way, if you have a course, for example, this course, the course ID is databases, right? So database can be only taken in campus. The second course and the third, all of these are taken in campus. For the fourth course, which is basically, I think this is digital forensics, can be taken on campus and it can be taken online. So one would say, how is the ID, which is a primary key, is redundant? That's actually wrong, right? How is there the 4 2 times? We discussed this, and this is actually a composite primary key that we have created here. And a composite primary key is just a combination of two attributes together. So together, these are unique, so there are no redundancies. And the same thing with 5. This course can be taken on campus and online, all right? And we've made the table takes, that is the relationship, many to many, but we didn't actually insert values to it, as I believe from the previous lab. I created a procedure for dropping tables, right? Maybe at some point you would want to drop the table, so you can drop the table one by one, or use something like that. Create a procedure that you can just execute it later on and drop all the tables, right? Maybe you would want to create them like all at once at some point. For some reason you want to drop them and create them again, so you have this procedure to do that. Unfortunately, if you remember procedures, I've told you that procedures are mainly used for DML, so insertion and stuff like that, but not DDL. And by DDL we mean dropping or creating tables, right? So if you want to use DDL inside the procedures, you would want to use this what we call dynamic query that is called execute immediate, right? So you need to say execute immediate before the drop table query. All right. I think this is supposed to be course avail, right? And cascade constraints is just about saying that if that table that I'm dropping was actually, if a column of that table that I'm dropping, for example SID, was referenced in another table, let's say takes or course, right? If this row that has an SID that is referenced in another table as a foreign key, if I deleted that row, then make sure to cascade that deletion in every other table that column is referenced in. Okay. All right. So that procedure for inserting the values, we did this inside the lab, right? There is something that I added this, of course. I said that we would want to have course availability. So let's say that we have the following courses. So course number 1 is databases, 2 is operating system, 3 computer architecture, 4 digital forensics, and 5 web development, and 6 VLSI, and 7 is circuits, right? So this is going to throw an error if you try to execute this procedure to insert all of these values, because for some reason you need to make sure that the main tables, right, the main tables have their values first, and after that you would want to insert the values that actually like for example the course available, all of the values that you are inserting to course available can be in its own procedure or can be inserted on later, right? The same thing with takes. Okay, sometimes this will throw an error because Oracle procedure or Oracle sequence in executing these rows isn't actually sequential as you may think. So you may think that Oracle is inserting these line by line, but that is not all the time the case. Okay, sometimes you would find that these couple of queries can be inserted or try to be inserted once, for example, the first course that has the ID of 1 has been inserted to course. Oracle might try to insert this to course available since the primary key of course 1 is already there in course, so it's going to try to reference it and put it inside Canvas, and you would not think that the execution is going to go back to course, right? Maybe the execution is going to continue to insert the other value to course number 2 who isn't there yet. Okay, so bottom line, if you have some insertions that is dependent on other values, right? For example, all of course available are dependent on the course IDs, which are primary keys inside course table itself, right? So these are dependent on these. All of these are foreign keys for that guy, for these values from the course, right? So if you have a table that is dependent on, like, have foreign keys that is dependent on primary keys from another table, just make sure that this is being executed in a different procedure. Okay, so I've made a procedure that is called insert values for CA or course available, and I've put all of these course available values inside of it. All right, and I executed these two insert values to insert in all and insert values to insert in course available. So let's check all of the values inside all tables just to recap. Okay, so we have all the values ready, but select all from takes. We didn't actually say which students are taking which courses, so we didn't actually insert anything to that. We are going to do this dynamically right now. So we are going to dynamically, you know what I want to say, right? So dynamically, I want to insert or enroll students from a specific department to all courses offered by their department. Okay, meaning that if we take a look at this, so if we have, for example, Heidi and Ziad and Tara, both of them are in department number 1. If we looked at department number 1, that's computer engineering. And department number 1 has actually the following courses. It has database, operating system, and computer architecture. So we want the 3 students from computer engineering to be enrolled in the 3 modules that is offered by the computer engineering department. The same thing goes for, let's say, Ahmed Magdi, for example. This guy is in department number 3, and Shabasi in department number 3, which is electrical engineering. Electrical engineering is offering VLSI and circuits, so we want to enroll these two students in the these 2 courses of the electrical engineering department. And Muhammad from department number 2, which is ethical hacking, right? You can see that ethical hacking actually is offering digital forensics and web development. So we want to enroll this guy in the 2 modules of the ethical hacking department. So how can we do this dynamically without inserting manually values like that? Okay, let's see that. So to actually know what this is going to be like, let's see, we want to insert the values to the take. If we want to say enrolling students from a specific department to the courses offered by these departments, so we want to say that the take table is going to be inserted. So let's see what does the take table has. So the take table has the following, right? So if you want to do the mapping for the take table, it has the SID from this guy, the primary, and the C number from this guy, right? So it has an SID and it has a C number. Both of them are foreign keys, and together they form a primary, composite primary key, right? So if you want to imagine what is the table is going to be having, so you can just say that this is SID, for example, and this is course number, right? And we said that, for example, Heidi right? From computer engineering department, this is for example department number 1, and this is student SID, right? So this student, for example, see, she's in computer engineering, and computer engineering department number, right? And the courses, you will find computer engineering is offering 3 courses, right? The first course, which is databases, DB. The second course, which is basically we said operating system, and the third course is computer architecture. Okay, so we want to say that this student who has the ID of 1, she is, let me just write this one more time, ID of 1, she is actually undertaking the following courses from her department's courses. So she is in department number 1, which is computer engineering, right? So you can just write the name here, comp, and comp, right? So from this department there are 3 courses. So she's enrolled in databases, number 1, right? And she is enrolled, the same student enrolled in operating system here, and she's enrolled too in the computer architecture, number 3. Okay, so this is how should the take table be like. We can manually insert these values via the insert table, the insert into. So you can just say 1 1, 1 2, and 1 3, meaning that the student ID of 1 is going to be enrolled in these 3 modules, right? But the thing is, we want to make this dynamically, right? So in order to do this dynamically, we need to see a way to get these values without us actually explicitly writing them statically, right? So if you want to get these values, you're going to see that the SID is in the student table, and the course number is in the course table, right? So we want to take that SID from the student table, right? And we want to join them with the course. But if you think about it for a minute, let's take a look at our schema here. We said that the student has an SID and it has a department number. It doesn't have anything related with the course, right? So from the student table, we don't have anything that relates us with the course, but we have a foreign key that is called department number that we don't really write in the finalized version, right? But we need that department number because we have that department number because of the belongs here. That relationship, that one to many, this many says that I'm going to take the primary key from the one side, right, and put it as a foreign key in this table, right? That's why we are seeing in the student the department number here. Okay, so and instead of going the path from this to this, we can actually do the reverse to that. We can say from the student we have the department number, so we can join the student, right, with the department. Now we are going to have a very big table that has a couple of columns that matters to me, a couple of columns that I care about, like 2 of them. Basically the SID, it's going to be having all of the columns from the student ID, and the main one from them is going to be SID, right? And it's going to have the rest of the columns from the department when you join them, but the main one is going to be the department number, right? And after this first join, we can do another join in course, right? Because department number, remember that department, if we looked at course, the course actually has a relationship with the department here. So the course has a department number, which is a foreign key that is referencing a department number primary key from department, right? So that's the same, this relationship is telling you that this is one to many, right? So the many side is going to take the primary key from the one side, so this is going to be having the department number as a foreign key, but we don't really, again, we don't write that in the final version, but that primary key from the one side is going to be inside the course, which is at the many side as a foreign key, right? And you can, hence you can join them. So if the resultant table from the first operation have SID and department number, then we are going to use that resultant table from the first join operation between student and department, and use that department number to join it on the department number from course, to join this and that, right? So the second join operation is going to have a bigger table that has all of these values plus all of the columns, right, from the course table, right, plus the C number from the course table and the department number, which is redundant, which is basically the same department number from the department. Okay, and bottom line is going to have, you are going to have the finalized table that is having the C number and the SID. And once you have all of this big table, you can just reduce all of these columns and just take the values from under this C number and under this SID and insert these two values into the take table. Right? So let's see how can we do that. Okay, so we know that the path now is going to be, we are going to join first, because remember the goal is to have under the take the SID and the course number, and there are no table currently that combines the SID and the course number, so you need to manually join the tables together till we have the SID and course number like at some of the columns at that resultant joint table. Right, so we're going to start, we can start by joining student and course, because basically the relationship here takes all of the primary keys, right? And we can't really use takes for the time being because takes is empty, it doesn't have any value. So we can really use this path, but we can start on this path since student and department has a relationship which is one-to-many, and this means that on the many side you are going to have a primary key from the one side. So student has a foreign key for department number from department. So you can join first of all student and department. So let's join student and department. Okay, so I'm just going to select everything from student, inner join it on department, right? On, remember that student has a department. I'm just going to name these as S and as D. So S has a department number, right, which is a foreign key to the original or the primary key, which is basically the same department number but from the D table, right? And let's see what is this going to be returning. Okay, so now this is the first join result. You have a very big table that has all of these guys. This is the left hand side, this is the table from the student, that's student table, right? And the right hand side is the table after the join, which is the department table, right? So this is the department table, I'm sorry, this is the student table. Okay, so it's the department number, which is a foreign key in the student. Say that this student is in 1, and 1 is basically the department number that is computer engineering. The second student is in department 1, which is a foreign key in student, right, which happens to be a primary key, which represents the computer engineering in the department table, and so on. Bottom line is that what we cater for, again, is that this ID, now this new resultant join table, it has the SID and it has the department number. We can use either one of these department numbers, right, that we have to join to execute the next join operation. Right, so if I have the department number from here, I can, or from the resultant table, I can join it on the course, since the relationship between course and department is one-to-many, meaning that from the many side you are going, or in the many side, you're going to take the primary key from the one side as a foreign key there in the many side. So I have the department number as a foreign key from the department, which is there as a primary key. So I can join these together. So the resultant table has department number, which means that all of the resultant table from this join can be used to join the resultant columns on the course by the department number. Okay, and just remind you again, the course actually has a department number, like we have the one that we've created in the previous lab. So we can continue in this join operations, and let's say that the resultant here operation here, we are just going to continue joining it. So I'm going to say inner join all of the resultant values or columns, right, on the course, right, and from the course department number, or that's the condition of the join. So from the course department number, which is a foreign key in course, I'm going to select all the rows where the department number in course happens to be there, existent as a primary key in one of them. It's not going to really matter, but I'm going to pick the one from the department table. So d dot department, like that. Course. Okay. So now the resultant table has Heidi, SID of 1. She is in department 1, and this department 1 happened to be computer engineering, and computer engineering having to have the following courses: database systems, C number 1, and data an operating system in the same department, right? And computer architecture in the same department, right? So Heidi is enrolled, or should be enrolled, in these 3 modules. Let's take Ziad, for example, SID 2. He's in department number 1, computer engineering. He's in database. He should take database course. Again, Ziad here in department number 1, computer engineering. He should take the operating system, and he should take the computer architecture. Okay. Now let's explicitly select, and selecting all of these columns, I just want to select the SID and the course number. And notice that I don't really need to use the aliases of the tables, because this is only occurring only once, and this is occurring only once, not like the department number. Right? So now you have Heidi enrolled in databases, course number, and Heidi again enrolled in operating system, and Heidi again enrolled in computer architecture. Okay, and this is it. You won't find any redundancies there. Okay, so this is basically the values that we need to. This is the selection. This is the displayed values that we want to insert into the takes table. Okay, let's make another more specific query of this. Let's say that I want to enroll students from a specific department to all courses by their department, offered by their department, while specifying the department number. So I want to enroll students from, for example, ethical hacking only to the courses offered by ethical hacking department. Right? Not all departments. I don't want to enroll all students from all departments, just the department that I specify. So I'm just going to take this and show you what I mean. So I'm just going to display everything for starters. So say that I want to pick students from computer engineering and only enroll these students that are from computer engineering into the courses offered by computer engineering department. So in this case, a DB admin can just offer the department number that he wishes to join the tables on. So I'm just going to join the students on the department who happen to be in the department number 1, which is computer engineering, right? And the resultant table, of course, is going to be students who are in the department number 1. So we should have only the first 3 students who are in the computer engineering department, right? Now I want to join these students based on their department number on the courses offered by the same department, which is basically number 1, right? So this is if you want to be more specific. Now you can see there is a little bit of redundancy here. I'm just going to use the distinct that okay, this is not correct. Yeah, I believe we need to specify exactly, because all of the columns, the combination of all of the values from all columns are going to be distinct. So we need to select specifically the SID and, for example, the course number. I think this is going to work. I think this is working, yeah. So if you take a look, you're going to see student number 1, who's Heidi, right? She is enrolled into course number 2, course number 3, and student number 1 is enrolled course number 1, right? And the first 3 students actually were only from computer engineering. So we have Heidi and Ziad and Tariq. So this is Ziad, he is enrolled in 3 courses. This is Tariq from computer engineering 1 and 2 and 3. So this is working. Alright? So let's put this inside a procedure. So I'm just going to copy the start of this right there, here. Okay, I'm going to call it insert or enroll all students. Enroll all students. Alright, and I'm going to take the ending statement here. So we will want to insert all student into the table that is called takes. Let me just make sure that it's called takes. Yeah, it's called takes, and it starts with SID then C number. Into takes, where the values is going to be the following. Is going to be the following. So the values is going to be coming from that query that we have written. This one. So I'm just going to paste it here, and don't type values, right? If you are the values that you're grabbing is being fetched from a query, then you don't need to write the word values. You only write the word values, or if you are inserting hard-coded values like that. All right. So let's just try this out, and I think there is a semicolon here. Now let's execute that. Now let's take a look at to display the values. And we're going to see students Heidi, for example, is enrolled in the 3 courses. The same for the other 2 students, 2 and 3. The one from electrical engineering are enrolled in the course number 6 and 7, and these are from computer engineering or from electrical engineering 4 and 5, and the one guy from ethical hacking is enrolled in course number 4 and 5. Okay, so let's make another procedure, but this time I want to be specific, and I want to just be able to insert the course number that, or the department number that I want to enroll these students of these departments in their courses. So enroll students. This is going to be the specific procedure, and this is going to be taking an argument, and I'm just going to make it of type number, right? And the variable name or the parameter is going to be called anything. We can just call this department number, like that. So whenever the DBA admin or anyone who's going to use this procedure is going to be passing this department number, I'm just going to place it here. Okay, and we said that we needed distinct in this one. Alright, enroll stud, and this is it. So let's try this, and let's delete first of all. Okay, something wrong. There is a semicolon, I think. Alright, so delete from takes, just so we can try it again. Alright, and let's execute this procedure, the one that we have just created. Enroll cell must be declared. Enroll stud. Alright, that's not the name. Wrong number of times to call. Alright, let me just pause this for a second. Oops, I forgot to add the argument here. So I'm just going to say that I want to enroll students in the department I think the department for computer engineering let's say the second department. I don't remember what was that. I think ethical hacking. Okay, so let's take a look. So yeah, we have enrolled students from ethical hacking into the courses of ethical hacking, and this is it, right? I want to give you another extra exercise here. So let's say that we want to list names of all courses who have a student with a GPA less than 2. So we can see that there's a relation that we need to, or a join relation between the courses and the student, right? So let's just take a look for starters. Let's start to do this with the normal inner joins or explicit joins, and I'm going to select everything from student and select everything from course, right? And let's see what does this entails. Okay, now let's say that we want to know the courses that people who have a CGPA that is less than 2 are enrolled in. What are the courses that these students have enrolled in? This student table doesn't tell you anything about the courses that these guys are enrolled in, but it tells you the department that they are enrolled in, right? So if you take a look at the department, you can actually join from the department. You can join to the course, right? And from the department we can join the course. Look at the course, you have a foreign key for the department. So if we join courses on department, on student, we can get to know the specific courses that these students are enrolled in, right? So let's start the join process. So let's say that I'm going to join everything, and just to remind you why we need to join the 3 of them, because we need to join the 3 of them because that the student doesn't tell you, as I said, doesn't tell you anything about the course, and we need to know the names of the courses, right? So we need the course table. So we need to know the name of the courses, so the course table, right? But we need to know the courses that have a student enrolled in them that is having a GPA less than 2. So you can't really link the course with the student unless you are using the takes, for example. So if we have the takes, we can join the student via course on takes. We need to know the course names, right, that students are enrolled in them who have GPA less than 2. So we need to know the course names. So we're talking about the course here, right? And we want to know which courses have students who have less GPA than 2. So we want to join course and student. You can't really join course and student unless you go through the mediator first, which is takes. So we can join student on takes, since takes by default has SID from there and C number from there, right? So we can join by the student SID on takes' SID, and from there we can join by takes' C number on course's C number, right? So let's select everything from student and inner join this on takes on SID equals TSID, and inner join this too afterwards from the takes course number. Oops, and inner join all of this, right? Now we have joined the student in takes. Now let's join the resultant on course on courses, or from takes course number on courses HSC course number. Okay, let's run this. All right, now let me just see here. This is not correct. Because the procedure that we have executed is basically enrolling students who are from ethical hacking only, that are in the department ethical hacking. Yeah, I remember that. Let's delete all the values from takes, and let's enroll all students to takes first, and let's execute everything again. And now we have here SID, student ID, for example, in department number 1, who actually takes the course databases and takes the operating system and takes architecture, and the rest is the same. Now we want to look for the rows that has students who are enrolled in some courses that has GPA less than 2. So you can easily just say where GPA is less than or equal to 2. Okay, so we end up with Ziad and Tariq, and this is correct. But now we want the course name only, so you just say CNAME. And you have these are the courses, and we can just put distinct there. So these are the courses that has students enrolled in them that has GPA less than 2. Another way to do that, if you want to use nested queries, is to do the following. Let's take a look at what we have in hand first. I'm just going to add select from takes. Nothing is going to really change. The idea is that you are going to work on the same 3 tables, but you are going to join them differently. Or in another word, you're not going to use the join operator. How about we start from the last bit of the query, where it says that list names of all courses who have student enrolled in them with a GPA less than 2. Let's start from the end of the query. Let's say that let's get the students IDs who have GPAs less than 2. So these student IDs who have GPA less than 2 is basically Ziad, which is SID 2, and Tara SID 3. So let's get these IDs who have for these students who have GPA less than 2, right? So I'm just going to start off with that. Okay, so I'm just going to select the SID from student, right, where their GPA is less than or equal to 2, right? So this is going to return 2 and 3, right, which is basically Ziad and Tor, right? Now let's add the S. I think we have the S name. What's it called? S name, yeah. Just to provide the name here. All right. Now once we know this information, let's take a look at the takes. Let's see what actually these guys are taking. So SID that has 2 and 3 are taking the course numbers 1, 2, 3, and 3 is taking 1, 2, 3. Right? So now if we know the SID, we can check what based on the SID from this query. Notice that, remember that this query is returning the following. Okay, remember that this query is returning the following. It returns 2 and 3. I can use this SID, which is 2 and 3, inside takes. So it's as if I'm saying, find me from takes. Let me just show you takes. Right? Find me from takes the course number that has an SID of 2 and 3. So 2 and 3 should return course number 1, 2, 3. It should return course number 1, 2, 3. So imagine that this query is returning something similar to this. It's as if it's returning the SIDs 2 and 3. Actually, we don't really need the S name here. Right? So it's as if it's returning the SIDs of people who have GPAs less than 2. So it's as if it's returning 2 and 3. Right? So now we can just say select all from takes, right, where the SID is one of the following. Right? It's one of the following, one of the results of this query, which is basically going to be either 2 or 3. Right? So it should return all of the rows that has an SID of 2 or 3, right? So if we execute that, so it's going to get you all the rows that has an SID of 2, so these are the course number, and SID of 3, these are the course numbers, right? Now, we want to know the course name. Takes doesn't tell you anything about the course name, but the course name is inside the course, so we need to take whatever values returned by this guy. So all of this is returning what, right? So for example, all of this query is returning something like the following. It's returning something like um, course number. We are actually focusing on the course number here, so I don't really want to select everything from takes. So let's say that I'm going to take from takes 1 to 3 and 1 to 3. Let me just run this one more time. We don't really need the SID anymore. So we have 1 to 3 multiple times, so you can just use distinct on this one. Okay. So it returns the course numbers 1, 2, 3. So now we can use all of this and say that this is going to be returning 1, 2, 3. Now pick me from course, pick me the rows from course that has a course number that is either 1 or 2 or 3. So the same thing here. I'm going to use the N operator. So I'm going to select everything from course where the course number actually is in one of the following results. It's either 1 or 2, 3. This is what this returns. Right, so I'm just going to make this like that, and this is here. Okay, so it's going to return database and reading system query architecture. Okay, it might seem difficult, but it's not difficult at all. So let's see what a correlated query looks like. Remember when I told you that a join is equivalent to a correlated query? Oops. A join is equivalent to a correlated query. Right? So let's go to the one that we have created, which is basically this join right there. Okay, and put this here. Right? And now let's say that I'm just going to go through this really slowly. I'm going to select everything from student. I'm going to take it in reverse in this case. I'm going to join course on takes, then on student. Right? So I'm just going to go through this, the same thing that we have done via the joins, but from the top or from bottom up. So let's join first course on takes. Alright? So I'm just going to select everything from course. Right? Where from course, right? You can give this an alias here. Since it's a correlated, I told you that correlation is like join, so you need to give an alias because there's going to be a condition. That's the point here. So from course, I'm going to select the course number, and I'm going to join it on the course numbers that I will be traversing via the following rows when I'm selecting course numbers, right? From the table takes, right? And just for the Oracle, so it doesn't get confused, I just want to say that I'm selecting course number from takes, right? Not from the outer one, right? Where the course number from course, which is the primary key, equals the course number from takes, which is a foreign key. Right? Okay. And now this is literally equivalent to saying that I am joining the course on takes. Like this is equivalent to this part, joining takes or joining takes on course, joining takes on course via this line, right? So this line is the same as this, right? So this, someone would say, as we've said earlier, that the N operator is used with nested queries. Not all the time. It can be correlated if there's a condition like this that relates something from the inner query with something from the outside query or the outer query, right? So if we run this, you're going to see that we have joined course on takes, right? So now you have joined course on takes. I think there's something that I'm missing. No, I think this is correct. All right. Now we need to continue joining the resultant here on student. Okay, so we want to do this part here, right? So we want to actually do this part by joining takes on student, right? Since we have takes already in hand, we can just continue on the where clause and say that I'm going to pick that takes SID, which is a foreign key, right, from the student's SID primary key, and check if it is in the following, or join it on the following rows, right, from student, right, let's give it an S, right, and we should mark it or map it to student's ID from the student's table only. So the operator takes only one or a set of values from one column, so I'm just going to provide one column instead of all from the student table, which is inside this inner query. And this is the correlation, the same as the condition under after the on, whenever you are using the join clause, where the T SID or the SID from the takes table equals the SID from the S or student table. Okay, so let's try and run this. Oops, I ran this wrong, so let's just run this one more time. And you would see that there's no difference at all, right? Because by the end of the day, we are selecting everything from course, and this is what course has. It has course number and CNAME and department number. Unlike the normal join, where you see all of the tables columns like adjacent to each other, that's not the same whenever you are like simulating the join via correlated queries. Because by the end of the day, this outer query is only what gets executed, right? So we have only the table or the columns that we get from course. Notice that we don't get any new columns from takes. We get course number, which is already in course number, which is already in course, right? And we, from this query, we get SID from student, which is already an SID. It's there in takes. So we don't really get any new additional columns than the one that we get in course that is displayed here, right? So we have joined course on takes and student, but it doesn't really seem that we have done so much, right? It is going to be different once we add the final condition, where we say that we want to select the SIDs, right, and map the rows that has a specific SID of a student, right, who is enrolled in a course, which that means that the SID is in takes as well, right? So select that rows that has similarities or equality, and make sure that the selected rows from students, not only that it matches with the SID from takes, but also the GPA from that row is less than 2.0, right? Notice once we hit this, you are going to see that now we have actually selected the rows from students that has a GPA less than 2, and these students happen to be registered or taking some courses, right, via this line, right? So we selected that rows of students who are taking courses that has GPA less than 2, and the rows that have been selected, right, we wanted to take the course number from these selected rows and see if it is there in the actual course table and map it to it and display it, right? So it's the same result as before. If this is confusing, you can just discard whatever I said and just get or do it via the join or the nested queries, whatever suits you, whatever you feel that is more understandable to you, right? I'm going to give you one last query here. So we want to retrieve the name of the courses that have more than 2 registered students, and notice that we're talking about the name of the course. So the S or the C name is only inside the course table, right? So let's select from the course. Okay, so these are the course names. Now we want the courses that have more than 2 students registered, right? Remember that we have 3 students from computer engineering registered in databases, operating system, and computer architecture. So we know this by hand or by heart because we inserted these values, right? But we want to know exactly how to query about them. So in order to know how many students registered in some course, we need to see what is inside the enrollment table or the takes table, right? Okay, So the text table is saying that you have a course number called 1 and it has a student, 1 has another student, 1 has another student, right? And course number 2 has a student, 2 student, 2 students. So 3 courses and 3 the same thing. It has 3 students here and there. So course 1, 2, 3, they have 3 students, more than 2 students, right? And course number, for example, 6, it has a student here and a student there. Course number 7 has 2 students. Course number 5 has 1, and course number 4 and 5 has only 1 student. Okay, so we can work on what text has, right? So let's say that I'm going to select everything from text, or let's just say the course number from text. All right, and let's see what is this going to be returning. So this is going to return 1, 1, 1, meaning that course number had a student registered in it, 1 has another student registered in it, and course number 1 has another student registered in it. Okay, so we can count, right? So we can add a count through these rows. Or before we count, we can do the following. We can just group by, right? So we can just say group by course number. And let's see what is this going to be returning. Okay, so we have everything grouped within a cell. So we have actually this cell that has 1, it has 3 1s, this 2 has 3 2s, and this 3 has 3 3s, and so on. So we can actually check the count of each row, and I'm going to say that this is count. I'm just going to call it count students, studs. I think this is going to throw an error, but let's just see. Yeah, it actually threw an error. No, I think that's the problem. Okay, so the first row, course number 6 has 2 students, course number 1 has 3, 2 has 3, 3 has 3. The ethical hacking course, we had only 1 student registered in them. That's cool. Now we want to get the rows or aggregates, right? Aggregates rows or super rows that has count of students that is more than 2. So we need to have only the course number 1 and 2 and 3, right? We can't really say something like where. If we want to check, if we want to perform some condition on a column that is a count column, an aggregate column, we can't really use just where. We can just use something like where count studs is greater than 2. This is going to throw an error, right? So where cannot be used with a column that is initially a count column. And instead of where, if you want to perform some condition on the count column, you can use something called having, and this is a special clause that only performs on count columns, right? So we can say having count students greater than 2. That's taking too long. Okay, so I think having doesn't like aliases, so you can just give it the count. So you can just having the count as greater than 2. Okay, so now we end up with course number 1 and 2 and 3, so these are the course numbers. But remember, the query should display the course name. So if we have the course numbers, you can just say something like this. I don't want really to display this part. I don't really want to display the count. I just wanted to show it to you. And notice that this is still going to work. That's totally fine, right? It just is not going to project or display the count as a separate column to the right, right? So if we know that the course numbers are 1, 2, 3, I can use the resultant value, which is basically something like this, 1, 2, 3, right? And put it in a nested query, right? And I'm going to put all of this in a nested query like that. post, right, and select CNAME from the course where C number is in the following, is one of these 1, 2, 3s. So we should see database and operating system included architecture.